All right, let's look at number 3. All right. It says Sally rented a car for $45 a week plus 12 cents for each mile the car is driven. What is the greatest number of miles Sally can drive the car if she wishes to spend at least $105? Okay, just like before, I'm gonna go through, I'm gonna start cubing the question to identify what's important, and then we will just go from there. Sally rented a car for $45. That's a key number. I'm gonna circle it. So she's renting it for $45 a week plus is a key word telling me to add, plus 12 cents for each mile. Each is a multiplication word, so I'm gonna use parentheses, and miles is a number. I don't know how many miles yet, but that's why I'm circling it, okay? And I'm gonna come back to this in a minute. What is the greatest number of miles? So here's the question. What is the greatest number of miles Sally can drive the car if she wants to spend at most is a key word telling me that the inequality I want to use is less than or equal to. All right, she wants to spend at most $105. All right, first thing I have to do is write my let statement. So that comes from the question. What is the greatest number of miles? Well, that's what I don't know is the number of miles, but I know that it's 12 cents for each mile. All right, so I'm gonna use M to represent number of miles. All right, and then I'm gonna solve from there. So anytime I see the variable M, I'm going to replace it. Anytime I see the word M, I'm gonna replace it with the variable M. All right. So it's $45 a week plus 12 cents times M, and that's gonna be at most 105. So this is actually the first question, guys, that we're reading where everything we've written is coming together perfectly. All right, so I can just write down exactly what I have. It's $45 just to rent the car. Renting a car, all right, that would be a one-time fee. You pay that fee one time, it's $45 to get the car. And then now that you have it, you have to pay extra for each mile driven. So I'm gonna pay extra, that's my plus. It's 12 cents for each mile. So I'm going to multiply 12 cents in M, and that's gonna be at most 105. So less than or equal to 105. Because again, I can spend $105, I can equal 105, but that's the most. I can't go any more. That is the most. I can only be less for the less than symbol. All right? It says, what is the greatest number of miles? Right now, I don't know. So I'm gonna drop a train track and start solving. Here we go. M is on the left-hand side. So am I gonna move 45 or the 0.12 first? I'm gonna move the 45 because these guys are besties. It's gonna be hard to break them up. We do that at the end. So what's the opposite of a positive 45? A negative 45. I'm gonna subtract it on both sides using that inverse operation. These cancel. All I have left is 0.12 M on the left. 105 minus 45 is 60 on the right. And again, M is hanging out with 0.12. When I have a number and a letter mushed together, mushed is multiply, the opposite is divide. All right, so I'm gonna use that inverse operation again, which is division. When I divide both sides, here we go. Let me type this in the calculator here. 60 divided by 0.12. Cool, it's an exact number. It's a nice integer, 500. And again, did we divide by a negative? No, so I am not going to change this inequality. It's going to stay less than or equal to. So when it says what's the greatest number of miles, well, it can equal 500 or it could be less. I'm gonna stick with the equal 500, so I'm gonna say she can drive 500 miles. Because again, this number that I'm gonna pick for miles has to be less than 500 or it needs to equal 500. 500 is a nice number. I can drive 500 miles in real life. All right, this makes sense, so I'm gonna equal 500. I do not have to go less. All right, cool, let's go to the next page. All right, let's look at number 4 here. It says Paul earns $25 per hour at his job. Each day, he spends $10 for lunch. Today, he wants to take home at least $215 after paying for his lunch. How many hours will he have to work to achieve his goal? Again, I'm going to cube the question, identify the variable, and go from there. Here we go. Paul earns $25 per, that's a multiplication word, hour. I'm going to let H represent hours here. All right, hours is a number. That's why I'm circling it. I don't know how many hours, but I know that H will be represented by that. All right, at his job. Each day, again, each is a multiplication word. Each day, he spends $10 for lunch. Today, he wants to take home at least $215. So if that's the least amount of money that he can take home, I know that inequality has to be the greater than or equal to 1, okay? And I'll explain this at the end. How many hours, here's the question, how many hours will he have to work to achieve his goal? So the question says how many hours, that's what I don't know, that's gonna be my variable for the question. H will be representing the number of hours. How many hours? I don't know. We have to solve to find that out. Now, I got to take all this information and put it together, all right? This doesn't look like it's going to be as nicely put together as example 3. All right, we kind of have to read into the question here. I know that I'm going to multiply $25 in H, so I can at least rewrite 25H. Each day, he spends $10. Spends is a subtraction word, all right? I know that each represents multiplication, okay? But I already used my multiplication word in the first sentence. So each day, again, it means to multiply, but I'm going to ignore that for the second sentence. They're saying each day just so that this grammatically will make sense as I'm reading the question. So each day he spends $10. If I'm spending money, that's money that I don't have, so I'm going to subtract that number away. He wants to take home at least $215. So here's my inequality for at least. 215 is the total amount of money, all right, at least 215. So he wants to have $215, so it's got to have that equal to, or he wants to have more, greater than 215, because that is the least, that is the lowest. So if he can't go any lower, he can only go higher, greater than or equal to. How many hours? Right now I don't know, so I'm gonna drop my train track and start solving to figure it out. Here we go. H is on the left-hand side, so should I move the 25 or the -10 first? You guys got it. I'm going to move that -10 by making it a +10. I'm using that inverse operation. That cancels. Now I have 25H on the left. 215 plus 10 is 225 on the right. The opposite of multiplying is dividing. So I'm going to divide 25 on both sides. This cancels. Now I have an H. 225 divided by 25. Let's type that in. Boom. It's a whole number 9. Pretty cool. Did I divide by a negative? No. So is my inequality going to change? No. It's going to stick as greater than or equal to. Here we go. How many hours will he have to work? Well, can I work 9 hours? Yeah, that makes sense. So my final answer here will be 9 hours. All right, I know that H has to be greater than or equal to 9, but I can work 9 hours, so I don't have to go more. I can just stay at 9 hours. All right, example 5. A little tricky, but we're gonna work it out together, okay? George must obtain an 85 average in his science class to keep his position on the school basketball team. His following test scores in science are 84, 80, 90, 75, and 72. What is the minimum score George must get on his 6th test to get at least an 85 average? Here I go. Let's start cubing the question. George must obtain an 85 average. That is his goal. That's the number we have to equal at the end. His following test scores are 84, 80, 90, 75, and 72. What is the minimum? Here's the question. What is the minimum score George has to get on his 6th test to score at least, that's the inequality that I'm going to use greater than or equal to 4. Okay, it's the same inequality as number 4, at least. We explained why, okay, to get at least an 85 average. All right. The only other really important keyword here that I haven't boxed yet is average. And I intentionally left this for last because I want to ask you guys something here. When you calculate your average for each quarter in school, how do you do that? Well, you're right. I'm going to take all of my scores, I'm going to add them up, and I'm going to divide by the number of scores I have. So here we go. I'm going to add all of my scores. So if I got a 90 on a test, a 65 on a test, I got 100 on a homework, I got, an 80 on a homework, I'm going to take everything I scored in quarter 1, right? I'm going to take all of those numbers, I'm going to add them together, and then I'm going to divide by the number of scores. So if I look, George has 1, 2, 3, 4, 5 scores, so he would be dividing by the number 5, the number of scores, all right? And when I divide these numbers together, I get his average, just like you guys in real life. That's how we get your average. We take all of your scores, we add them together, we divide by how many there were, and that gives you the average. Okay, so before we jump in and start actually finding the average, I have to put a variable on the side. The question says, what is the minimum score? So I'm going to let X be my variable, and I'm going to say that X is the minimum score, right, that George can see. All right, here we go. I'm going to add all my scores. Right now, George got an 84. An 80, a 90, a 75, and a 72. So I'm going to take all of those scores and I'm going to add them up, and then I want to divide by how many scores there are. Now be careful. The question says, what is the minimum score he has to get on his 6th test? His 6th test. This is only 1, 2, 3, 4, 5 tests. I want to add on what his 6th test number would be. Right now I don't know, so that's why I'm letting it be represented by the variable X. So when I'm dividing, I'm actually dividing by the number 6, because even though I don't know what this is, I am going to find it out. All right? And he wants his average to be at least an 85. So it's got to be greater than or equal to 85. All right, let's start solving this and making it a little bit simpler for ourselves. So on the calculator here, I'm going to do 84 plus 80 plus 90 plus 75 plus 72. Those are the 5 scores that we know he got, okay? And I get 401. So I get 401 plus X on top, because I know all of these guys are like terms. So when I combine them together, I get 401 plus X. Okay, when I divide, I'm still dividing by the number 6, and that's still going to be greater than or equal to 85. Now, this is a 7th grade topic. If you have a fraction on the left, that means I want to make a fraction on the right. I know that I can put any number over 1, because 85 divided by 1 is 85. All right, these guys are equal. When I have a fraction on one side and a fraction on the other, who remembers? Throwback question. Who remembers what that's called? Yeah, you guys are crushing it right now. It's called a proportion. How do we solve proportions? By cross multiplying. Okay, this is probably the hardest step to have recognized that this is what you're going to do to finish off number 5. Here we go. Anything times 1 is itself. So I'm going to get 401 plus x is greater than or equal to. Well, what's 85 times 6? If we type that into our calculator, 85 times 6, we get 510. All right. And now I solve this like any other inequality. I drop my line. All right. X is on the left-hand side, but there's only one number for me to get rid of. It's 401. So the opposite of a positive 401 is a negative 401. All right, so I'm going to subtract that away. Now all I have left is x. 510 minus 401 is 109. I didn't divide at all, so this is definitely not going to change. It's going to be greater than or equal to 101. So if I reread the question at the top, what is the minimum score George has to get? Well, he's got to get 109, it looks like, on his next test if he wants to reach his goal. 109 on his 6th test. All right, because again, I should be greater than or equal to 109. He can get 109 on his test, so I'm going to equal 109 for number 5. And then last but not least is number 6 on the back. All right, I want you guys to try number 6 on your own and then just check back for the answer when you're done. Okay, so at this point, please pause the video. You really need to try at least one on your own. I'm sure you guys are gonna do great. All right, and then check back for the answer. All right, and here is number 6. It says Allison has $35 to spend at the pet store. So if she has $35, that's how I know this inequality needs to be less than or equal to. So I'm gonna add that up here right now because she can be spending $35. It can equal 35, but it can't be more, okay? If anything, it would have to be less. Less than or equal to 35, that's what she can spend. She buys, when you guys go to the store and you buy clothes, you buy shoes, you buy food, whatever it is you're buying, you take everything you bought, right? Which was a $15 dog bowl, $8 dog shampoo. She also bought some dog bones, okay? What are you doing with all of those items you're buying? You're adding them together, all right? So just keep that in mind. When you're buying, sometimes we might think subtraction, I guess, just because we're spending money. But you have to think when you go to the store, you add up everything you bought and then you got to pay, right? With the amount of money that you have, she's got 35 bucks. So I'm going to add up the $15 dog bowl, the $8 shampoo. And then here's the tricky part. The dog bones were $1.25 each. The question tells me that the number of dog bones is being represented by the variable X. So I wanted to save this part to do with you. The dog bones, which is X, they cost $1.25 each. And we know that each is a multiplication word. So I wanted to multiply, all right, $1.25 and X together. That's why I did that in the first part. Write an inequality. This is the inequality. I have my let statement. X represents the number of dog's bones. All right, and then part B says to solve. Here is all my work. Okay, when you guys go to the store, they can't cut a dog bone in half. You can't buy 0.6 of a bone. All right, so if I look at my inequality, it says I can be 9.6, but that doesn't make sense, or I can be less than 9.6. So I'm just gonna cover up, okay, that decimal at the end, so the answer should have just been 9. 9 dog bones, that is how much she can buy. All right, if we look at the closure, which is at the bottom, okay, that's for you to complete. It's multiple choice. Please make sure you are identifying all the key information in the question to get that done. And then last but not least is your homework on the back. All right, make sure that you are getting the homework done as well, identifying all the key information, okay, and then again, carefully writing your inequality and then solving it down below. Crushing it, have a good day.